Okay, let's start. I'm very grateful that Rob Godwin has time to talk about space, the history of space stations. I'm super curious myself, and I'm very happy that you will also have the possibility. Robert Godwin is well known in the space sector, especially in the field of space history. His work and he himself has been interviewed and seen on lots of different channels, BBC, CNN, CBS, Discovery Channel, History Channel, of course. He was a space curator at the Canadian Air and Space Museum. I got to know that his work became very famous because he wrote a book about a Scottish minister named William Leitch, who was obviously the first scientist to propose rockets as the best method for powering spaceflight. And with that book, Rob Godwin rewrote the history because he found out a lot of new facts. Another interesting book that I liked is Manned Lunar Landing and Return. Here he tells the story of lunar crewed landing, especially about the Project Malar. And he's also writing a new book. And today he will present a little bit of a book that he was contracted by NASA. So it's the history of space station. He will explain more. Robert Godwin is a member of the National Space Society and the Space Frontier Foundation. He's also a dear colleague and member of the International Academy of Astronautics based in Paris and the Astronautical History Committee and also the Astronautical Society History Committee. Over the last years or over his work lifetime, he has interviewed and written about a lot of astronauts, for example, Buzz Aldrin and Wally Schirra and also Neil Armstrong and Harrison Schmitt. And what is very nice is that a main belt asteroid is named after him. So he is in the sky for ever. It's called 4252 Godwin. Because of his efforts in documenting space history, this is a real big honor, right, Rob? So
it was a wonderful birthday present.
Oh, a birthday present, nice. We have hello, Carmen. We have another guest. Hey, interesting Austrian from the Austrian Space Organization. Okay, I let you start, Rob.
Okay, well, before I share my screen, I'll just explain a little bit about how this came about. NASA approached me, the International Space Station Office approached me to do a book about the 20th anniversary of International Space Station, of the first launch. And I agreed to do that. And my role in that book specifically was to try and put together a history of all of the different serious designs and ideas that had been conceived over the years for how to build a space station and indeed why to build a space station. So the book originally was presented chronologically, and I've tried to turn that into a hour-long presentation for you, hopefully that will work. And there's a lot to cover, and so I'm going to have to go quite quickly. And I beg all of your forgiveness if I mispronounce the German names. So I will switch to screen share here.
Rob, I think best is that we put the questions in the chat and we go through them after your talk, right?
Okay, that sounds fine.
Okay, thank you.
Does that come up on your screen there, Sandra? Are you able to see the presentation?
Wonderful.
Okay. So I'm going to start with initially the question, why build a space station? And the list of things that you see on the left were in fact all things that were figured out very early on by both the Russian Hermann Tsiolkovsky and the German Hermann Oberth. And as you can see, most of those things are still being considered, perhaps not the weather control, but most of those things are all still things that space stations are proposed and used for. I managed to add 3 more things at the bottom, which those 2 gentlemen didn't originally come up with, and those are the manufacturing, tourism, and possibly colonization. The first instance that I could find of the term appeared in Oberth's 1923 book, Weltraumstation, and that was then translated into English in 1930 by Hugo Gernsback in his magazine Air Wonder Stories, where he first used the expression stations in space. So we're going to begin right at the very beginning here. The first person to actually propose a space station for a scientific reason or for a practical reason was Edward Everett Hale, who you can see at top left, and he was actually the minister of the US Senate at the time. And he wrote an article called The Brick Moon, which appeared in Atlantic magazine in 1869. And it was really the first published concept of a manned space station. It was going to be a 200-foot diameter sphere that would be launched by a flywheel into polar orbit. It would have had a crew of 37, and he suggested that it needed to be built from brick to protect it from solar heat. He anticipated that there would be low gravity and that the crew could perform what he called superhuman feats. He also envisaged that there would be lots of them, multiple launches, and because they were in a polar orbit, they could be used for calculating longitude and also for navigation by that very purpose. So it was sort of like a GPS of the day. He figured that zero gravity was a feature rather than a problem, and he had no suggestions or ideas for artificial gravity. Also, it would have all been assembled on the ground. Nothing would have been assembled in orbit. Immediately following him, around 1883, was the Russian Konstantin Tsiolkovsky, who you can see with the beard there at the top. And he created sketches of humans living in space around 1883. And those are 2 of his drawings immediately below him. The one on the left, I think, is from 1880 or so. And the one on the right is actually from a later album of his. That's from 1933, where he considered having a glass roof to allow sunlight in for growing crops. And you can see that he has crops growing both on the floor and the ceiling, and the crew in zero gravity. He thought of sunlight as a resource rather than a problem. He was immediately, or not immediately followed, but around the same time, a little bit later, Hermann Oberth came up with his idea for the Weltraumstation. His ideas, he didn't actually create drawings of them that we could look at today. Some of these drawings you see on the right are from later on. But he proposed having 2 modules on the end of a 20-kilometer long cable for artificial gravity. You would spin them for artificial gravity. He also thought that it was important that large mirrors could be launched into orbit, and these would be manned. And so you're seeing an illustration of those at top right. And those could be used to focus solar energy in the form of light or heat to the ground. And you can see that pictured at bottom right. His idea was then picked up and expanded upon by the German journalist and author Otto Willi-Gale. In 1926, he came up with what he called the astropole, which you can see that sketch just next to him at the bottom, and a diagram of it or a picture of it at right. He was building on Obert's ideas of also still having the mirror for using to control weather, to melt ice on the ground, to bring light to dark places like the North Pole in the wintertime. And his space station, the Astropole, would have been spinning to create artificial gravity. But what he missed was Obert's point, which was that to have artificial gravity that actually would be functionally useful, you really needed to have a very long diameter between the rotating nodes. And as you can see, his drawing there on the right at the bottom, the habitation module is on a very short leash. At bottom left, I've included my favorite man, Reverend William Leitch. He was a Canadian, and he proposed asteroid colonies in 1861, as well as proposing rockets for space flight. And he suggested that asteroids could be mined for resources, and indeed people could live inside them if they wanted to. I'll come back to asteroid colonies later. Moving on, we get to, I've got to try and pronounce this man's name, Guido von Pirke. In 1928, he proposed a thing called the Außenstation, which would have been 3 space stations, all at different orbital altitudes. One in a 100-minute orbit, one in a 150-minute, one in a 200-minute orbit. And each would be used as a refueling stop, which he thought would dramatically reduce propellant needs to get to a higher orbit. I'm not an engineer to be able to say whether that was a good idea or not, but he was the first to come up with that. He was immediately followed by one of Sandra's favorites, Hermann Nordung, or Potocznik, who came up with the Vonrat, which you can see, that's a 3D wireframe that I created of it in the middle there. And then on the right is a picture from the cover of one of Hugo Gernsback's magazines. He published a book called The Problem of Space Travel, where he had a balanced, what we call a toroid, I don't know what the German word is for it, in a spinning wheel shape, and a solar mirror that would generate steam power. He also had a separate observatory module that would be flying on long cables away from the main habitat module. He proposed putting it into a geosynchronous orbit, a 24-hour orbit. Obert criticized the radius of his zero gravity as being too small, but it was the first balanced rotating toroid, and it addressed the problem suggested by Otto Willy Gale's Astropole. The solar mirror would drive a steam turbine, which was the dominant early power concept for powering a space station. The same year, the Irish philosopher John Desmond Bernal proposed a thing which became known as the Bernal sphere. And this was where ambition really went very extreme. It would have been 10 miles in diameter, built from asteroid and planetary debris, using almost no Earth materials, with a transparent outer shell and electrical systems that harvested sunlight. This idea would be revisited, as I said earlier, by Jerry O'Neill. One of the things that Werner von Braun did, which is not known about very much, certainly not here in the English-speaking countries, was his essay that he wrote at school in 1930, where he wrote about a space station, which he called the Lunetta. And again, it would have been a spherical module with an orbiting gravity cell on the end of a long cable. He had a co-orbiting mirror station located 200 kilometers away, so that you can see that his initial idea for a space station was based on Obert's and Nordung's ideas. What was interesting is that von Braun's mirror would have been 350 kilometers in diameter. By 1945, Arthur C. Clarke of the British Interplanetary Society had formalized his idea for what he called extraterrestrial relays. In actual fact, his original paper, which he submitted for publication, was called The Space Station. And it would have been 3 space stations, all 120 degrees apart at geosynchronous orbit, 22,000 miles above the Earth. And the idea being is that all 3 of them would be able to communicate with each other constantly and provide telecommunications to the ground 24 hours a day. What is generally not spoken about is that Clark actually believed that these space stations would have to have been manned. There was no thought of unmanned satellites at that time, not just yet. So he was the first to write a paper called The Space Stations. The following year, another figure who generally doesn't get spoken about much was Donald Ritchie. He was a member of the Detroit Rocket Society, and that particular group of engineers corresponded a lot with the German rocket societies immediately before and after the war. And in 1946, Ritchie published his ideas and drawings for what he called the Space Terminal. He was operating from some of the documents that had been captured at the end of the war, and he came up with this idea for a 16,000-foot diameter space station, which would have had 2 rings, and you can see that drawing at the bottom there. One of the rings would rotate while the other wouldn't. And this sort of was a unique solution to the idea of artificial gravity, which subsequently I don't think anybody picked up on. But it became very well known. His drawings appeared in newspapers all over the world in 1946. And that was the first time that this sort of donut, as we call it, donut-shaped space station appeared in the literature. The following year, Wernher von Braun came up with what you see in the middle on the right-hand side, which was his first, what he called, again, it was called the Lunetta, I believe. And it would have been made up of inflatable components. So you can see it has about 20 sides on it. It also has what's called a point focus solar heating array. So that large dish that you see is concentrating sunlight to a point focus boiler in the center of the toroid, and would provide solar power that way. It would have all, as I said, almost all inflatable and 150 feet in diameter. Bottom right was the British Interplanetary's 1948 design by Harold Ross and Ralph Smith. This would have been a 200-foot diameter toroid, again, gyro stabilized with what's called a line focus trough heating for the boiler. So you see the solar reflector there, the big dish, and running around, you can see the arrow just pointing at that dark gray ring in the middle. That would have been holding some kind of fluid that would be heated up by the sun, again, from that rather large dish. It would have been steam, I think, that they were proposing to use. Independently, they kind of came up with this idea. They didn't really know very much about Noordung's ideas at this point, but they also added Arthur Clarke's transmitter, as you can see at bottom left. So it was going to be a sort of a hybrid of Clarke's suggestion of a telecommunications station as well as a orbiting laboratory. Moving on, we get to about 1949, and Heinz Gartmann and Otto Willi Gale continued on with the Außenstation and still were proposing this idea. You can see now that the habitat is not a sphere on the end of that arm anymore. It's a sort of flat, half of a sphere, I suppose. And the idea that the crew would be standing on that flat surface. This didn't go very far, but Gartmann was one of the co-founders of the International Astronautical Federation, so his idea was taken very seriously. Arie Sternfeld was a Russian who his ideas were actually quite hard to find, but those two schematics or drawings you see at the top right were the Russians' ideas, and you can see you've got the toroid, much like von Braun's on the right, and you've got something like the Astropol, Gale's Astropol on the left. So the Russians were following something of a parallel path. There was probably a lot of reading of each other's stuff. This was followed in 1951 by Hermann Köhler and Helmut Herpner. They called theirs the Außenstation again, and they came up with the heavy lifter rocket, which they called Optimal Raketen. Those drawings you see in the middle show their ideas for designing and building what would have been what we call in English, it's a bespoke design, where you create something specifically for the purpose. This was going to be a heavy lift launch vehicle that would carry modules into space, and then they would be assembled in space in that circular pattern that you see on the right-hand side blueprint. They called it the rosary in English because it looked like beads. This was the first time anybody said, look, we need to build a rocket specifically that can carry specifically designed modules to create and build the space station in orbit. And to do that, to accomplish that, they also came up with a one-man assembly spacecraft, which you can just about see in the middle there. I don't know if you can see my mouse here, but right about there was a little one-man vehicle that had grappling arms on it that would be used to assemble the space station. So they presented that at the London IAC conference in 1951. And as you probably know, later on, these ideas started to reoccur. Herpner also came up the following year with the image that you see at bottom left here, where he designed two specific sort of shuttle-style rockets that would dock end to end and then would be used to spin up and create artificial gravity. Again, this is something that's sort of still being considered in some circles today. The following year, we get to Wernher von Braun's larger version of his space station. And this one was considerably larger than the original. Sorry, I'm jumping ahead and pressing the wrong keys here. Considerably larger than his original one. This one would have been 1,000 feet in diameter. And it also, again, used the line focus trench. So this is the solar reflector running around the edge here. And the red line is where the liquid was that would have been heated to provide power. And here's von Braun himself holding a model of it in 1952. Spinning for artificial gravity, but with a much larger radius to be able to satisfy Obert's rule about what would be useful for artificial gravity. This was going to be constructed in orbit, and it would have been a hard shell space station. It was not inflatable. And here you can see what is a cutaway showing through the side of it. Here is the reflector, and here is the boiler, which would have been filled with mercury in this instance, cooling pipes around the reflector. And then you can see that the crew would have been standing facing their feet facing this way, so that gravity would have been down to the sort of outwards from the perimeter. I'm going to move on. So once we get into the 1950s, von Braun and most of his team of scientists had been moved to Huntsville, Alabama, and were now working on all kinds of more elaborate designs. One of the first to come out of that particular group of people was Kraft Ericker's observation satellite, which was designed by when he was working at Bell Aerospace. You can see now these very long arms for rotational gravity, and sort of a low gravity modules in the center for docking and so forth. Around the same time in Russia, Tsiolkovsky's original designs were seeing a resurrection. Here you can see the glass roof that Tsiolkovsky proposed for his greenhouse, and this would have been filled with gardens and trees for providing oxygen and food and all this kind of thing. This is a schematic of this here, right here. The following year, into 1955, a fellow called Darrell Romick, who worked for Goodyear in the United States, proposed this enormous space station, which would have been 3,000 feet long, 1,000 feet in diameter here and 1,500 feet in diameter here. He considered it would be, he called it a small city in the sky and serving as an outpost. And he also came up with a huge reusable launch system for building and servicing this particular thing. One of the things that was also proposed was using what's called spent stages in English, where you start to use part of the rocket as a counterweight for artificial gravity. So Kraft Erika came up with this design, which he called the EMSS, in 1958. There were multiple different versions of it. In this one on the right, you can see that there's a shuttle docked to the side of the center of the vehicle, and then two counterweights, one the staging and one the engines down here, would have provided the counterweights for spin up. This is a later or similar version and a later version down here where he developed all the different kinds of things that you would need. You notice that he has radiators for getting rid of heat down here from a nuclear reactor. And this was one of the very first to propose using nuclear reactors for power, and a water condenser at this end, waste disposal and so forth. Around the same time, Kraft Erika's designs were introduced to the Army Ballistic Missile Agency, which is where von Braun was working. And they started to develop these ideas further. And so they presented these three different styles, which they called Terra 1, Terra 2, and Terra 3, to the US Army for the purpose of them to decide whether they wanted to build a space station like this for military purposes. Further on into 1958, the American contracting community started to get involved. And these two gentlemen, Saunders Kramer and Richard Byers, came up with a design for another toroidal space station, which would have looked much like this here. And they had various different designs. And this went through a lot of different stages of design and was being pitched to the US government. Again, this was just before NASA. So this would have been being pitched to the US military. The following year, Herman Köhler and had moved to America. He had been brought to America and was now working with von Braun at the Army Ballistic Missile Agency. And in early 1959, the Army had decided that there was a national security reason for perhaps having a moon base. And they thought that if they had a moon base, that they would control the high ground. And so Köhler and his assistant, Frank Williams, were given the task of coming up with a system for actually being able to launch something large enough to build a moon base and then design a moon base. And so they came up with a program called Project Horizon, which you can see is illustrated here, 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 and also down here. This would have been a refueling depot in orbit. This was the large lander with its translunar injection stage right here, and its orbital stage, boost stage here. These would have been 3 orbital fuel tanks, manned. There's actually a manned part to it. And the lunar rocket would go up, dock to these fuel tanks, refuel, and then go to the moon. And many of these spent stages that you would have had would have been left on the moon and turned into habitats. Now, some of you may recognize this idea because this is exactly what Elon Musk has been proposing for the last 4 or 5 years, is launching lots and lots of large rockets, docking them in low Earth orbit, refueling them at a fueling space station, and then taking them to the moon. Köhler figured out in 1959 that unless they had a very, very big, efficient rocket, they were going to need at least a dozen launches to actually make this valid and be able to get one vehicle all the way to the moon. So Elon Musk is reinventing the wheel right now and figuring this out the hard way. If he'd just read Project Horizon a long time ago, he would have realized that this is what he was going to have to do. Same year, Chance Vought Company, and these gentlemen down here, particularly the man in the middle, whose name was Conrad Lau, came up with a thing called the Satellab. And this is a 3D model that I made of it from the blueprints. This is an actual drawing of the model here. And this would have been an orbital space station using a large fan-shaped solar collector, because at this point in 1959, solar panels were becoming a valid idea. They were becoming efficient enough that they could possibly be used for powering a space station. Again, Elon Musk, when he first came up with one of his ideas for an orbital spacecraft, it looked almost exactly like this, with the large fan-shaped solar panels. But in 1959, solar panels were still considered to be a very new technology, and they weren't sure if they would be efficient enough for powering a space station over long duration. You might notice that the Satellab also has a space telescope at the end here, which was revisiting something that Obert had proposed back in the 1920s, and also Tsiolkovsky. These three men went on to take this idea and develop a lunar landing system, which they then presented to NASA the following year, and NASA adopted almost all of it. Jumping ahead the next year, what you're seeing at top left now is where Curler and Frank Williams were taking the large booster system that they had available to them, or at least they thought they would have. It was called the Saturn C2, and they were going to use it to launch a ready-built space station. They could use it to launch a tanker, a cargo carrier, or a space station. And this is, again, derived from the Project Horizon plan for building a moon base. So here you see the various different options that were available that they could put on top of this large booster, which Curler himself designed, I should point out. Werner von Braun did not design the Saturn. Curler came up with it first. It was called the Juno 5. The same year, an engineer called Dandridge Cole at the Martin Company came up with a whole concept for large colonies, space colonies, which he called macro life. And he had these huge vehicles which could land on asteroids, taking an entire habitat with them. Later on, he then proposed hollowing out asteroids, much like William Leitch had suggested 100 years earlier, and turning those into large mobile space stations. The same year, Kramer and Byers at Lockheed were now pitching their ideas to NASA, because NASA had now been formed, and they came up with something that was derived from Curler's ideas, where they would use these sort of modular sections and construct them almost sort of like a Lego set. And this would rotate around the long axis. So they had a nuclear reactor at one end and a docking station at the other, and the entire thing would rotate around the long axis. Again, stolen from Curler, they came up with this one-man construction module, a sort of mini spacecraft just for assembly. And you can see the various different parts here. The same year, 1960, it was a busy year. A fellow called Gerd de Beek, the Army Ballistic Missile Agency, was doing artwork for NASA and proposed this entire space village, where this would have had a hotel and a hospital and all manner of habitats and so forth. Meanwhile, the Douglas Aircraft Company were back to proposing inflatables, and these would have been inflatable, sort of flat pancake shapes almost, which would be connected together around a inflatable corridor. And of course, Goodyear, who was famous for making blimps and airships, came up with their own ideas for inflatable space stations. The advantage to using the inflatable was that it would fit in one piece inside what the Saturn C2 was capable of actually lifting. And the problem with it, of course, was that you couldn't really install anything inside it until it was inflated. So you could take the sort of main construction part as a single inflatable, put it on top of a Saturn C2 and send it up, but you still had to man it and equip it once it was up. Sorry, I don't know if you can still hear me. Can anybody hear me? Sorry, my microphone just died on me for some reason. Okay, so moving on, 1960 to 1962, Chance Vought, working with Köhler at the Marshall Space Flight Center in Huntsville, came up with an entire architecture for manned space exploration, which they called orbital launch operations. And this would have been an entire series of developments of space stations growing larger and larger over a period of time between 1963 and 1972. So this was a sort of a one-man spherical module. The sphere obviously was understood to be the most stable structure for holding pressure differences. And so they started out with the spherical using the fan solar power, and they had something sort of similar to an Apollo command module that would dock to it. They then expanded it to a cylindrical shape. This is what the inside of one of those cylinders might have looked like, with sort of a food storage at the bottom, control panels, an airlock at the top, and a bathroom and bedrooms at the top. Again, this was expanded further. Now you have this long arm on the side, which has a nuclear reactor on it, which is kept at a distance for obvious reasons, to protect the crew from radiation exposure. It carried on to the point where they were proposing now to use cylindrical modules in a toroid shape for artificial gravity. Again, the very same reasons that had been proposed many years before. But now you can see that the nuclear reactor is out on an arm on the central axis here, again, removed from where the habitat is for radiation reasons, but in a sort of a low gravity situation. Now you can see another version of it here, which looks a lot like what Saunders and Kramer had been proposing with their plans at Lockheed, but this became part of the OLO concept. At the same time, Köhler's people were proposing having these separate modules that would be separated out and flying separately, that could be used for low gravity experiments and to shield them from radiation and electromagnetic interference from the main space stations. So you're sort of back to what Nordung had proposed back in the 20s. The Martin Company came up with this, which was their own design for an inflatable. Again, this was all being constrained by the size of the Saturn that they believed that was going to be built, the Saturn C2. They carried on with this design. These gentlemen here, I forget their names now, but they had also a hard shell version, which they called the MSOL, and that stood for Manned Scientific Orbital Laboratory. And you start to see something that's beginning to look a little bit like what actually became the first launched space station, which was Skylab. Moving ahead, Convair Company, because you understand all of these different contractors were competing with each other to see who was going to build a space station. This is the Convair Company's designed by a guy called Freeman de Vincent. And from 1960 to 62, you can see he now has that very long tether. And this is the spent rocket stage. And here's the habitat spinning around the tether for artificial gravity. They actually built a full-size mock-up of the tassel, which is what it was called. And they built it and actually put people in it and tested it for several years. He also had a smaller version, which would have, you can see here, has a Mercury capsule docked to it. The NASA Langley Research Center, working with Goodyear, actually built this not full size, but half size mock-up of an inflatable space station in 1962 to see what kind of pressure that it could take. And I believe if you dig on the internet, you might even be able to find some footage of them testing this thing until it explodes. Aeroneutronic, which was a division of Ford, came up with an assortment of different small space station modules that could be used at the time of the Mercury spacecraft. And you can see there's all these different iterations and designs. Most of them would have required the astronaut to get outside and spacewalk to get into them. What you see here is a large-scale mock-up model of one of the Saturn C2 rockets. So you can see how far they went with this design to see how it was going to look. And again, North American Aviation, 1962, was looking at putting a full inflatable space station in this, the C2, and then inflating it in orbit, as you can see in the picture here. The same year, the Manned Space Flight Center in Houston, NASA themselves, a fellow called Owen Maynard, who is well known here in Canada because he's a Canadian, came up with this self-deploying space station, which was called Olympus. And the idea being is that these wings would deploy, and then you would have a gravity gradient between the center core and the edges of the space station. And this was given a lot of serious consideration because Maynard was a brilliant guy, and in fact was one of the principal engineers of the lunar lander, the Apollo lunar lander. Around the same time, just a little bit later, a fellow called René Berglund, also at the Manned Spacecraft Center, but also working with North American Aviation and Langley Research Center, came up with this six-sided hexagonal inflatable with solar panels that would deploy along the sides of them. And again, docking for an Apollo in the center here somewhere. He actually won an award for this design. And you can see that it would have been launched on something starting to resemble an Apollo Saturn on the right there. George von Tiesenhausen of NASA Launch Center in Florida came up with what he called an orbital launch facility. You then have what looks like this is another nuclear reactor on the end of an extending arm. So it would deploy like a piston, and then they would fire up the reactor. You have multiple different laboratories and so forth, and docking of Mercury space capsules around the bottom. This was proposed in 1963 as part of the orbital launch facility designs for orbital launch operations. The Douglas Aircraft Company weren't going to get left out, and working with NASA Langley, they came up with MORL, which again I can't remember what the acronym stands for. Got it here somewhere. Anyway, it doesn't matter. This was using what you might recognize or start to recognize here was a Saturn IV stage. It has multiple engines on the bottom, but this was the original design for the third stage of the moon rocket, the Saturn V. And now you see that it has Gemini spacecraft being docked to the side of it. So it was being configured to be able to handle NASA's two-man spacecraft. And again, like Tiesenhausen's design, you've got these different layers for different functions. And this evolved further over here. You have a version of it, which was a large space telescope. And the guy who designed that, he actually gave me all of his blueprints for that. And it's about 4 feet thick, the binders that he gave me for this space telescope design. Extraordinary amount of work went into it. Boeing were also not being left out of the orbital launch facility designs, and they came up with this, which they again was a version of the Manned Orbital Research Laboratory, the MORL. And you had a hangar for docking. You had orbital launch vehicles. Now, this is the first time again since Project Horizon where they're proposing to launch from the space station to the moon. So they called these orbital launch vehicles. And you have fuel tankers docked up on the bottom here. These are all different versions of those things. This is a Boeing diagram showing the different configurations and ideas that this could be used for. Carrying on, the military were not going to get left out. And the US Air Force came up with a thing which generally is known today as MOL, Manned Orbiting Laboratory. But it went through many different iterations. That originally it was the Military Test Space Station, MTSS, and various other different designs. All of these are specifically built to be launched by the Air Force on a Titan missile. So this is an Air Force graphic at the bottom left here. You can see a Titan with a Gemini on top, and this is actually, sorry, this is launched on a Titan. And you've got all these different designs being proposed by all these different agencies. And you might notice this one at the top, the two-man, looks very much like what Helmut Hepner proposed in 1952, with two of them docked end to end and launching shuttles or re-entry vehicles on either end. There was also versions that would have used something that was starting to look like Apollo, which you see on the right here. In the end, a full-size mock-up of the manned orbiting laboratory was launched. Here's a picture of the launch on the large Air Force Titan 3C rocket. That entire program, the manned orbiting laboratory program, was canceled just after the assassination of President Kennedy. The Air Force under Lyndon Johnson decided that a lot of the things that they were planning and proposing were not going to be functional because they were too expensive. Carrying on, Lockheed had now taken Owen Maynard's design from the Manned Space Flight Center and done their own version of it with wing-shaped solar panels, and now a docking node in the middle for an Apollo to dock to. And this was their version of a manned orbiting laboratory. Around the same time, I believe it was Boeing came up with a thing called the MPMM, and it was a forget what the acronym stood for, but it was a standard-sized cylindrical module that could be launched and stacked, and you would just move your crew, navigate through them, different modules like this. This became something that they seriously considered, and all kinds of different versions of it would continue for the next few years. At the same time, Lockheed was proposing something that would again rotate around a central axis with 3 habitat modes and a shuttle specifically designed to supply it. They called it the Bucephalus. Douglas came up with the MOSS. I'm never going to be able to remember all of these different acronyms, but they had 2 different versions of it. One was solar panels, and the other one was what they called Brayton turbine system, which was using the old school heating of some kind of fluids to provide power. So this technology for power had been sort of circumvented by solar panels for a while, or by nuclear, and now it was being reconsidered again for an assortment of reasons. Not to be left out, over in Russia, Sergei Korolev and Vladimir Chelomey were competing with their own designs for space stations. This was the Soyuz A space station, which you can see is an assortment of modules with a Soyuz lander, Soyuz re-entry vehicle at one end. And Chelomey came up with a thing which was called the Almaz, which was originally designed to compete with the Americans' manned orbiting laboratory. It was going to be a spy satellite, a manned spy satellite. And you can actually see there's an enormous telescope camera here at the bottom, which would have been pointing at the Earth. So oddly enough, these 2 gentlemen were competing for funds in Russia, for the same funds, and making it difficult for themselves. Grumman, back on Earth, was still looking at rotational gravity. And between 1963 and 1969, they came up with an assortment of different designs that would rotate. This is with a spent stage and the habitat on the other end. And this is an assortment of different bits put together. I forget exactly which parts. And then you've also got this Y-shaped axial rotation, which was something which was considered seriously for some time. Atomics International, which was an American corporation, came up with their own version of a nuclear-powered orbital space station, which was not particularly original. They were mainly interested in trying to sell nuclear reactors for space. You can see 2 Gemini spacecraft at the bottom. Lockheed and Aeroneutronic, which was Ford, came up with these long plans for interplanetary missions that would use spin-up gravity. But some of the designs for this would have been placed in orbit around Mars, or placed in orbit around Venus, or around the Earth. And these were called the Empire studies, and those went on for several years and were very complicated, complex plans that were put together for space stations. NASA Langley and North American took the 180-inch cylinder and devised a thing which they called Apollo X as a possible small space laboratory with an Apollo command module docked here. This was evolved into an assortment of different Apollo lab concepts because Apollo was now starting to evolve. I'm rushing here now, but I'm going to keep going. Tell me if I run out of time, Sandra.
Please do.
The Apollo Applications Program was what they were considering to do after Apollo had successfully been to the moon. What were they going to do with all of that hardware and the designs that they'd come up with? So this was the beginning of using the remains of a Saturn 4B third stage of the Saturn moon rocket as a possible habitat. And again, the problem with this was that if you launch it full of fuel, you've then got to send all of the equipment up later. You've got to empty the thing out, pressurize it again, and then start bringing the equipment in. So that was the beginning of what went on for several years. And you can see these different iterations of it. You can now see an Apollo docked at one end here. You've got what was called the LEM telescope mount. This is using the lunar lander from Apollo without legs as a telescope. And they thought, well, we've already got this design for a space-friendly, man-rated pressure vessel. Why don't we use that for a manned space telescope module? So they actually built a full-size version of that, which you can see in this photograph. Von Braun was the one who eventually said, we should just launch this thing with ready equipped, called the dry workshop. We wouldn't actually launch it with fuel in it, would launch it empty. Meanwhile, over here on the right, you can see General Dynamics is now taking these cylindrical modules, which I think were actually a pretty good idea, and building models of them. This is a photograph of a model showing what it might be like inside one of them, and showing all the different applications that you could use by stacking these modules in such a way that you can put them lengthwise like this. You could stick them on the side. And you might notice at the bottom now, we now have the space shuttle starting to creep into the ideas. This is another version, became the rotating I-type station. Now you have a Saturn second stage here. This is the Saturn II stage, which is a much larger rocket with three of those cylindrical modules on the end of, I guess these are pistons, with an Apollo docked in the middle and solar panels. So this would give you rotational gravity, not very helpful because again, the length of the radius of the rotation is not very good. Kraft Erika hadn't done yet. In 1966, he proposed this design for a orbital space hotel when he was working at Convair. And again, this was rotational, but you'd have all these different stacked modules on arms like this. And at one point, the Douglas company took Erika's design and suggested this version of it, which actually would have been a hotel. First design for a space hotel. We now get to what was called the Donlin Group at NASA. And this was a combination of Manned Space Flight Center, Marshall Space Flight Center, Langley, and Kennedy Space Center, all working together to come up with this design where they would stack all these modules and then have telescopes on the end, various different laboratories. At the same time, Douglas Company came up with the Earth orbiting space station, which was similar with these, again, stacked layers. You might notice that there's no rotational gravity on any of these now. The Douglas Company also said we should build a commercial space station, something which you might have also read about in the press recently. And it would use these stacked modules, various different docking facilities on the side, an extended nuclear power plant again, and they could make this larger and larger. And this would actually be built by corporations for private scientific use. Boeing suddenly realized that they could potentially launch an entire space station inside the Saturn II, which was the second stage of the large moon rocket, which was much bigger than the Saturn IV. And they would be able to launch this in one go, they thought. And again, Boeing spent a lot of money in 1967 looking at how to power this using solar panels and various different forms of solar generation of power, experiment sensors for studying the Earth, emergency escape vehicles. So you can start to see this becoming more complicated. Robert Gilruth, who was very famous in the history of space exploration, took the idea of the Saturn II as a full space station and pitched his own idea for it, which is what you see here. Now you see these incredibly long rotational arms. So Gilruth was back to saying, well, if we're going to launch a huge space station in one go, this piece here, we should still have rotational gravity because we can now extend the arms. And as you can see, you've got these stacked layers again. Gilruth's plan also had a separate flying separately manufacturing module, which was separated from the main space station for the purposes of keeping it insulated from radiation from the power plant and from electromagnetic noise and so forth. It could fly in a different orbit. Eventually, we get to the point where Marshall Space Flight Center in Huntsville, working with all the other NASA centers, is now starting to create something that looks like Skylab. These are three different versions. I think they were numbered B0, B1, and B2, and they all showed different versions of what they thought Skylab would ultimately look like. It wasn't called Skylab yet, though. At the same time, they were coming up with other versions, which you see here, of the modular version with these stacked cylinders still. And I forget the man who came up with that particular one. Now we start to get serious in 1969 because Apollo is starting to come to a close. You get what was called the Phase B studies. And this is taking that huge Saturn II space station, which I might add, they built a full-size version of. Here it is here, this little photograph. And they trained astronauts inside it. And it was going to be taking over from where the Apollo moon landing program ended, where they would have all of these different versions that were proposed for how to use these huge space stations built out of the Saturn II stage. There were going to be this version, which it's a sort of Y state, they called it a Y version, which would require 2 Saturn V launches. This one would be 3 launches, 5 launches, 6 launches. And ultimately, it would become known as the space base. NASA spent 3 years going through all of these different permutations and spent a lot of money working on them. And ultimately, it was to be called the space base. Now, the idea of this was that it was for a full architecture for getting to Mars, as well as establishing permanent presence on the moon. And I won't bore you with all of the little details here of all these different design concepts. But ultimately, this whole thing would be integrated to a nuclear propelled vehicle, which would then take some of these modules to the surface of Mars. They also looked at using the thing for nuclear shuttle refueling. You can now see space stations docking to it in various different permutations, and it's become quite an enormous thing. The 1-man or 2-man crew servicing vehicle has now evolved to something that looks like this. And Grumman was still throwing in their ideas into the mix here around 1968, which was still a rotational modular stack. The first space station was launched in 1971 by the Russians. It was called Salyut 1 or OKB-1. And the only photograph of it that was taken of it in space is that picture right there, because they had all kinds of problems with that first launch. However, the Salyut went on to become arguably the most successful space station program that we've had so far. There were, I think, 7 of them total. I think this is Salyut 7 right here. Here it is under construction in Russia. And as you can see, it's powered by solar panels. It's got no rotational gravity. It's just modular. It's stacked. Here is a schematic of Salyut 1. This is the Soyuz vehicle at one end here, docked right there. And then the rest of this is a space station. And although one of the crews perished, coming back from a Salyut mission. There was nothing to do with the space station. That was not the problem. Back in the United States, the idea of Apollo was pretty much done. The Saturn V rocket had been canceled, and the idea of the Saturn II space station was thrown out with it. And so now the space shuttle program was the prime objective for NASA. And so the space station designers had to completely rethink what they could do. And they had to design something that could be launched the way that Curler had first proposed back in 1951, using modules that would fit into a specifically designed vehicle that could carry specifically designed modules. And so we went through all of these different permutations. You have Convair and General Dynamics using it for launching research modules. You have what they called the maximum cluster here, which was docked sort of almost to provide a gravity gradient, a very small gravity gradient for some experiments, maintained by the shuttle, different permutations. Again, you can see this is the Y shape. Large solar panels are starting to appear in almost all of these designs. Finally, the United States launches a space station in 1973, the Skylab Orbital Workshop. And as you can see, it looks very much like what von Braun had finally proposed, to launch a Saturn IV. This was the very last launch of the Saturn V rocket, the moon rocket. And the Saturn IV stage here is now a fully equipped space station. No gravity gradient, but the Apollo telescope mount was to be mounted on the side. It was no longer pressurized. There's no longer an Apollo lunar lander here. And it was to be launched in one go, with all of these solar panels and solar arrays to be deployed in one go. Now, you might notice in this photograph that there's only one solar panel on this side and one missing here. That's because this one didn't deploy. And there was also another problem, is that this section of the station was overheating. And so the very first crew to go up there had to dock and spacewalk somewhere that nobody had been expected to spacewalk. There were no handles anywhere along here. And they had to go out and try and deploy the arm. They were unsuccessful on this side, but this shade, this sun shade, was deployed by sticking something out of a little tiny port that was here for an airlock. And it was a brilliant piece of design that saved the entire program because it caused the temperature to cool down again in here. This is a view looking down inside Skylab, and you can see that the floor is designed with these triangles so that the astronauts could fit their boots into this mesh, and it would hold them in place so that they could support themselves when they were doing experiments. This is what the Apollo Lunar Telescope mount ended up looking like before it was launched. Carrying on from there, they hadn't forgotten their modular designs, and these ideas of cylindrical drums that could fit now inside the space shuttle were becoming more and more common. But in the meantime, a guy called Gerard O'Neill at Stanford had taken the idea of building enormous space colonies. And what you see here is the O'Neill Sunflower, which was this massive space habitat, and what became known as the Stanford Torus. This is orders of magnitude much bigger than anything else that anybody else had proposed. And he wrote a book called High Frontier, which I was very proud to be publisher of. And NASA spent a ton of money on this as well, on these studies to come up with these huge space colonies. And they're still considered to be the sort of litmus test for designing space colonies. Johnson Space Center and Grumman came up with this version of a space platform using something similar to the Skylab. We have NASA now getting firmly involved with something they could actually launch. They called it the Space Operations Center. You see the stack again, large solar panels. Rockwell came up with their own versions right here. This is the proposed assembly timeline for that, showing each piece that we brought. So you're starting to actually see the beginnings of what actually happened later. 1982, modular concepts by Douglas, Johnson Space Center, and now you see all of these different possible construction designs where they would put the modules in different configurations. And there was the raft, the racetrack, the figure eight, all these different possible shapes. This is the raft version right here. Meanwhile, this gentleman, John Hodges, another Canadian, was put in charge of designing, opening the International Space Station Working Group. It wasn't international yet, it was just the Space Station Working Group. And from 1982 to 1984, he and his team worked up all of these different designs for space station possibilities. This was called the Delta. It looks like the mathematical delta symbol, the big T. I'm not quite sure what the purpose of that was exactly. This was called the Power Tower, and it had huge solar arrays going out either side, and starting to look a little bit like ISS. The NASA Space Station Task Force came up with something a little bit more conservative. This is because in Washington, the funding for this whole thing was constantly going up and down depending on who the president was. And so you start to see these different smaller versus larger designs. This one had this enormous 100-meter phased array antenna to be deployed from it. And it now had industrial processing labs on board and logistics modules and outdoor pallets for doing experiments in vacuum. 1984, again, a lot more of the same kinds of things growing in size and scale. This is TRW. This is McDonnell Douglas. Meanwhile, the international community had been invited on board, and you start to see things being offered by European Space Agency here. Oddly enough, this is the Canadian, this is actually a commercial for de Havilland, Canada from 1962, proposing that they could build a robotic arm for docking spacecraft to a space station. So the Canadarm idea was something that Canadians had been pitching since 1962, and it had continued to be pitched on Skylab, but was rejected until it was ultimately accepted. So anyway, you now start to see all these different, this is the JAXA, the Japanese Space Agency's module. Funding suddenly went up again around 1985 to 87. I believe that was I can't remember if that was Reagan. I think that was Reagan. And they started to look at all of these big permutations again. And this became known as the dual keel because it had these two huge possible keels for launch, for housing experiments and so forth. And you could almost imagine this doing rotational gravity, but it didn't. What was interesting here is that you have solar panels, regular solar panels there. Down here, you now have solar dynamics again as an alternative for providing power by heating up liquids. So for a brief time in the mid-80s, solar dynamic power was back again. The European module would have been mounted in the center there. And the Japanese module you can see right here. I hope you can see where my mouse is pointing. We're almost at the end here. The baseline configuration agreed upon by the international community looked like this. This was 1987. You've got all your modules in the middle, your solar arrays out in the ends. Solar dynamic power is now gone again. Meanwhile, the Russians were not standing still. They launched Mir, which, as you can see, is somewhat derived from the designs for Salyut, but are considerably larger. And by the late 1980s, we now had a joint program between the Russians and the Americans, and the shuttle was able to now dock to Mir, and lots of international astronauts, including Europeans, went in and out of Mir for several years. Something not generally known was they also had this station called Nadezhda, which had this huge habitable pressurized module in the middle. This was a design the Russians had at the time, which was cheaper because they were having funding crises as well. The Iron Curtain was about to come down, or had come down. They had these two designs for Mir 2, which you might notice again was using solar dynamic power and solar panels. So you've got two different potential power systems here for both. And I managed to find the blueprints for both of these in some obscure Russian website, and was able to create these 3D models of them so that you've got some idea of what they look like. This particular one was going to have a European module on it. This is when the ESA was cooperating with the Russians to put their own module onto Mir. So as you can see from these diagrams, you've got solar dynamics and solar panels on all of these different possible designs, the solar dynamics at the time. More corporations were pitching their own small industrial facilities. This was a company called Space Industries, Inc., for manufacturing in low gravity. We now have got to the point where it's become known as Space Station Freedom. And it starts to look a lot like ISS did. It was redesigned briefly to look like this underneath the Clinton administration. No solar dynamics anymore, no nuclear power, just solar power. By this point, solar panels have become much more efficient. We also have these ideas for various different modules that could be attached or associated with ISS, or Freedom as it was known at the time. They changed the name briefly to Alpha Mir because now the Russians were going to provide Soyuz docking equipment and various different energy modules and so forth. And then finally we get to what became known as Space Station Alpha, and then I guess that was the last name that they had called it, Alpha Station, and then they changed it to International Space Station Alpha. And these are both slightly different. So the sort of summary here is that artificial gravity went in and out of fashion, so did inflatables. Power systems were constantly competing. The construction methods were generally the same ideas. There were only a couple, inflatables and modular really, or used stages. The scale of these things was always controlled by budgets. You always got the same kind of response: smaller stations, fewer launches, more modules. And ultimately, the ISS ended up a chain of 125 years of accumulated design, mostly dictated by engineering, but also by politics and funding. And so all of that is explained a lot better than I just did it in this book, which we published. And if anybody's interested, I have all of about 20 of them left because NASA bought all of them. And that's the end of my presentation. I hope you could follow me.